So welcome to my presentation. My name is Arthur Carvalho, and that's a joint work with Majid. I am at Pharma School of Business, Miami University of Ohio, and Majid is at California State University, San Marcos. Our work is about how blockchain can bring trust and transparency to the payment of crowd forecasters. So our work is really applied in nature. Just to give you some background information, crowdsourcing platforms like Amazon Mechanical Turk and Figure 8, they allow us, anyone, to hire thousands of people all over the world. And one specific task is becoming more and more common inside these platforms, which is the crowdsourcing of forecasts. Just to give you one specific example, think about this question I have in my screen now, which is a real life question posted on the Good Judgment Project, which is a crowdsourcing platform. The question asks which presidential candidate will win Pennsylvania, and then anyone, any person can go online and report a forecast. For example, my forecast here is 75% will be the Democratic person, 25% will be the Republican candidate. We're interested in our work in settings where the forecaster is hired to report a forecast, and eventually the forecaster will receive a payment in return. That payment is dependent on the quality of the proposed forecast. And by quality here, I mean it depends on how accurate the forecast is or how good the forecast is in predicting the events of interest. The problem now is when you measure the accuracy of a forecast, you need a realized outcome. And that realized outcome will only happen in the future. So if we go back to the election scenario I discussed before, we have to wait until the end of the election to see the candidate who won the election and eventually measure the accuracy of the forecast. As a consequence, the forecaster only receives money in the future, so the payment is only issued in the future. And that is a tremendous issue in crowdsourcing settings because by nature, labor and contract laws are very weak in crowdsourcing platforms like Amazon Mechanical Turk. We have come across situations where requesters asked for a forecast, and eventually, after receiving the forecast, they did not pay the forecaster, mentioning that the forecast was just random or carelessly reported. So what we want to do is to avoid situations to make sure that a forecaster receives a payment once a forecast is reported. So we base our solution on smart contracts and blockchains. So I'm going to now explain how our solution looks like. It's just a bird's eye perspective of our solution to the previous problem. So the main point about our solution is we will develop a contract between a requester and a forecaster. That contract is coded as a smart contract. The smart contract is a bit long. I have just the main points on my screen now, but inside the smart contracts, we have the requester's address in the blockchain, which is the requester's ID. We have the forecaster's address as well, so we know who is requesting and who is reporting. We also have the payment scheme that's used to evaluate the forecast. So now the forecaster knows how his money or her money will be defined, will be calculated. We also have the source of truth. We have to somehow retrieve the realized outcome. Within the blockchain context, these truths are called oracles. So the oracle is well defined inside our smart contracts as well. So now both the requester and the forecaster, they know where the realized outcome will come from. We have two other points in our smart contracts as well, which is the deadline for the forecaster to submit a forecast and the date after which the realized outcome is available. So these are the main attributes in our smart contract, and all of them are publicly viewable. Now I'm going to go through the steps that the requester and the forecaster will go through when using our solution. So the step number one, we have the requester developing the smart contracts and posting the smart contracts on the blockchain. Together with the smart contracts, the requester must fund the smart contracts, must send some money to the smart contracts. At this point, the smart contracts behaves as an escrow account. So the smart contracts now has enough money to pay the forecaster, no matter how accurate the forecast is reported by the forecaster. So that will be the step number one. Once the smart contract is deployed, eventually the forecaster in the future can submit a forecast. The smart contract will receive a forecast, will check if whether all the probability values are good, if they're between 0 and 1 and they sum to 1, whether the forecast was reported before the reporting deadline, and so on. So if the forecast is acceptable, if all these conditions are satisfied, we can eventually in the future call the blockchain again, call the smart contracts, and request the smart contracts to retrieve the realized outcome. We can have either the requester or the forecaster initiating that process, initiating that request. So whenever I say Oracle here in our work, in our presentation, that's just an API endpoint. Inside our smart contracts, that's just one URL pointing to some website. So eventually the blockchain, after the request, the blockchain will talk to the Oracle and retrieve the realized outcome. The step number 4, the last step, is now either the requester or the forecaster can ask the smart contracts to release the money. So the forecaster will get some money based on the reported forecast, the realized outcome, and the payment function inside the smart contract, and the requester will get the leftover, the escrow money minus any payments issued to the forecaster. So that is a bird's eye perspective of our solution. We argue that our solution boosts trust because the forecaster is always paid. As soon as the forecaster reports the forecast, from that point on, there's no way for the requester to avoid a payment. And perhaps the most important point here is that contracts enforcement is automated. So that is the basic premise behind smart contracts, in that we can force a certain contracts to be enforced, if you will. The second bullet point says it boosts transparency. So our work, we argue that it boosts transparency because payment scheme is really well defined within a smart contract, plus the source of the realized outcome is unambiguous. Both the requester and the forecaster now know where the realized outcome will come from. So just to explain now the current status of our work and finish my presentation with some open questions. In our current status now, we have a full prototype up and running. We developed a smart contract using Solidity. We developed a user interface that will interact with Ethereum, the blockchain we deployed the smart contracts to. Throughout our working paper, we use design science, the classic paper by Peffers, to guide the development of our system. In terms of theoretical background, we are using one specific news vendor model to kind of provide some theoretical background for our work. Just to finish my presentation now, I might be running out of time in a few seconds, but I have 5 open questions that we are hopefully we're willing to get some feedback, and hopefully we'll get some feedback from you. Number 1 is how to evaluate our work. Any ideas how to evaluate our system? Number 2, what would be the most appropriate theoretical background? We thought about news vendor and principal agent model. Number 3, what would be perhaps the most appropriate design science research framework to follow? Number 4, which angle should we explore? In my presentation now, I'm talking about crowdsourcing. In our working paper, we have changed to supply chain risk management. And number 5, what are the potential issues that you can see with our solution? And with that, I'm going to end my presentation. My contact information is there, my LinkedIn as well. So please feel free to stay in touch.
Okay, thank you, Arthur. We have about 6 minutes for questions. Arthur has presented really good cogent, 5 cogent questions there. And if anyone can be of assistance, I'll open the floor up for questions.
Arthur, this is Theo, and I have a question. And it's not a question, it's a clarification. Could you use the example of the opening slide to explain the logic of your approach?
Absolutely. So let me go all the way back to that example right here. I'm not sure if you can still see my screen now.
Yes.
Perfect. So let's say that you and me, we are somehow, I'm the requester and you are the forecaster. So the very first step is I will develop a smart contract. in that smart contracts, I have your blockchain address, I have my blockchain address, and I have an URL that will specify the winner of the election down in the future. So all these attributes are stored there. So as the requester, I will post my smart contracts on the blockchain. Now, instead of going to a web interface like you have here, you will go to some well-developed interface where you will actually provide a forecast as well. That forecast will be stored in the blockchain, through the smart contract. Now we have the forecast is stored in the blockchain. Eventually, we can see the observed outcome in the future, the realized outcome, and you can ask the smart contract to issue a payment based on the forecast that you reported before. The only difference I would say is primarily the background technology. We could have an interface like I have in my screen now, but that interface will be talking to the blockchain, and eventually that interface will allow either the requester or the forecaster to retrieve the realized outcome and to ask the smart contracts to issue payments as well.
So in a case like this, the oracle will be the decision that was after the November 3.
Precisely. That's precisely what it is. Because the thing is, how do we know which candidates won the election here? We have to somehow specify the source of truth. It cannot really be you or me, because we can manipulate the outcome. I can say something and you can say something else. Now we have to agree somehow on one specific API or one specific endpoint that will tell us that is the candidate that won the election. And that's pretty much one URL. That URL will say that, for example, candidate X or candidate Y was the winner of the election.
Okay, have we any further questions?
Hi, Arthur. My name is Kevin. Can I ask a very, very naive question here?
Absolutely.
Why use blockchain rather than just a centralized database?
That's an excellent question. The whole idea here is we want to avoid potential manipulations. So if you have a centralized database, that can in theory be manipulated somehow. Or we can even think about the Good Judgment project that I have in my screen, or Amazon Mechanical Turk. These are proprietary platforms. Even in these proprietary platforms, things can be manipulated. For example, as it happens right now, inside Amazon Mechanical Turk, if you submit a forecast, I can always say that your forecast is no good and avoid paying you. And that's it. You cannot really sue me. There's no problem there. Using a blockchain platform, we can automate the whole thing with smart contracts.
I'm sort of, I worked in a business that uses the crowdsourced model. It was I won't say the name of the company, but basically it's one of the large search engines, let's put it that way. And again, the questions, the majority of the questions coming in from potential crowd workers was around payment and sort of ambiguity within that whole structure. But what you're suggesting there takes that whole debate away, because it's completely transparent.
Precisely. And that was one of the questions I faced as well when I was a PhD student years ago. I was working with forecasting, and I actually crowdsourced the forecast task. And most of the people on Amazon Mechanical Turk, they just reported 50-50, like kind of a careless forecast. And I was annoyed to a certain degree, because I had this bunch of flip it coin kind of answers. But what my PhD supervisor said at that point in time is, Arthur, that's perfectly valid. I mean, that's not, you have to pay them regardless of what they reported. So in theory, I could just stop and say, I'm not going to pay you because whatever reason I have, I would be allowed to do it with no consequences whatsoever. And that's what we want to prevent here. We want to make sure that even if you have a poor answer to a question, you still get paid.
What you'll address there will be the recruitment and the churn of the people that participate in the program, because that's where the major cost is. Sorry, Trevor, I'm taking up too much time.
That's fantastic. It's been a fantastic presentation, and I'm sure there's a variety of questions, and Arthur put up 5 really strong questions there. So if anyone would like to get in touch with Arthur, please do so, because there's really some good questions there that would help Arthur out. Thanks again, Arthur, for this presentation, and it was really good.